Okay, so let us begin. So, origins of science. Science is not a European enterprise. There seems to be a general feeling that science is what the Europeans did, and that actually is not true at a very fundamental level. Scientific inquiry started when humans first began to look at the working of nature. They noticed the remarkable consistency in the working of nature, and they also noticed high degree of reproducibility in response to nature and their action. So, for example, when they would make stone tools, cutting the stone at a particular angle always give you a very sharp edge, and so on. They soon began to build up this knowledge and started a scientific inquiry into the working of nature that we call science in today's parlance. All cultures, all civilizations have contributed to it depending on their capability and their environment. Today, we will talk about the journey of cultures and civilizations that made Indian subcontinent their home. So, we are going to remain focused to our subcontinent. The important thing is that science is not a human alone environment, in the sense that other animals have also used tools, but humans have been more systematic. So we restrict our discussions to humans. But for example, you have birds that use stick to get nuts, or chimpanzees that they or use sticks to get white ant outs because they like to eat white ants, and so on. Homo sapiens, earliest Homo sapiens, the archaic humans, are about 1 million years old. They already use flake tools by about 500,000 years ago. Incidentally, the other hominoids, Homo erectus, etc., are known to have used tools as far back as 2 million years ago. The earliest evidence we have for humans is Homo sapiens sapiens is 500,000 years ago. But even in India, we have found stone tools that go back to about 1.8 million years in a place called Adambakamba. Beautiful work by Shanti Papu and others. But anatomically, modern Homo sapiens sapiens appear in 20,000 years ago. So the brain size reaches about 1500 cc, which is true today, and so on. But even though they arise 50,000 years ago, the behaviorally modern, in the sense of living in groups, living in some form of family units, etc., is about 50,000 years old. Humans spread across Africa 200,000 years ago. Humans made their first bed, in the sense that we have evidence where a whole bunch of twigs and leaves have been spread on the ground, roughly the width of a human being. So we believe that it was a bed. And that dates to about 200,000 years ago. The earliest jewelry, in the sense of seashells with a hole in them, obviously to put a thread through, dates to about 135,000 years ago. The evidence that we have for controlled fire goes to about 125,000 years ago. Language, it seems, in the formal sense of the word, emerges about 100,000 years ago and then spreads as Homo sapiens spread. Migration out of Africa is about 100,000 years ago. So even though they spread across Africa, they crossed northern Africa into Palestine and then eventually into Europe and Asia about somewhere between 100,000 and 70,000 years ago. The earliest evidence we have of humans wearing clothes is about 70,000 years ago. And the earliest evidence we have of traps being laid to catch animals is also about 70,000 years ago. Bow and arrow were invented as far back as 64,000 years ago. So they could see bamboo and they could see its elasticity, and therefore tie up a string to it to make bow and arrow is something that is 64,000 years old. Later humans spread out of Africa and Europe before they became behaviorally modern. Behaviorally modern humans fully adapt to their brains and body control and social structure, etc., come, like I said, about 50,000 years ago. Then there is a sudden rise in creativity around 40,000 years ago when cave art, musical instruments appear in Spain and Germany about 40,000 years ago. Female figurines of a few centimeters in size come up in Germany about 35,000 years ago. Pottery gets invented in China about 20,000 years ago. Constellations and their designs are dated to as far back as 15,000 years ago. There is a Lexus Caves in France where you have found the earliest drawing of constellations. Then another major phase comes about 12,000 years ago when farming and animal domestication starts occurring in Central Asia, which would eventually lead to Sumeria and so on. Metallurgy is also appears 10,000 years ago, but this is largely copper and bronze, metals that can be isolated from a sample at relatively low temperatures. Iron takes much higher temperature. Writing was invented 8,000 years ago in West Asia, as far as we can tell. Wheel and related technology is about 5,000 years old in Mesopotamia, present day Iraq. And both these phases, of course, I mean, when I say it is 5,000 years, it is not 5000. There are a few hundred years on either side. There are margins to it, but this seems to be the general pattern. Then recent humans. So horse is domesticated about 6,000 years ago in Central Asia. Bronze and coppers are discovered and used in India about 5,000 years ago. So Harappans were a bronze age civilization. Pyramids are built about 4,500 years ago. Harappan cities were built about 4,500 years ago, and they last for about 1,500 years or so. The first major religious text, Vedas, can be dated to about 3,500 years ago, even though some of the contents can date back to as much as 6 or 7,000 years or even earlier. Mahabharata is dated to about 3,300 years ago. Iron was discovered toward the end of Mahabharata 3,300 years ago in Central Asia and in India. So Mahabharata itself has a discussion about Krishna having discovered iron in fire and so on. Greek civilization peaked around 3,000 years ago, obviously in Greece. The Persian transcontinental kingdom, the first genuinely transcontinental kingdom, comes about 2,500 years ago, which spans all the way from the Hindu Kush mountains into um, definitely Palestine, but even beyond into Spain and so on. But that is about 2,500 years ago. So that is 500 BC. Just to continue, Vikram Samvat calendar begins 2072 years ago, when the king Vikramaditya of Ujjain started celebrating his victory in 4058 BC with a calendar. The Shaka calendar, which is also followed in many parts of the country, comes about 1993 years ago. And that was when Satvahana king Gautami Putra, Gautami Putra Satkarni, initiated the Saka era after his victory with against the Sakas in 78 AD. Ghazni invaded India about 5,000 years ago. European expansion with guns, germs, and magnets and steel began about 500 years ago. Babur came to India about 500 years ago. Taj Mahal was built 400 years ago. Telescope was invented around 400 years ago. The steam engine, central to the internal combustion engine that would run a whole bunch of automobiles, etc., in early ages, was invented 300 years ago. Aircraft was invented about 100 years ago. And just for a comparison, I am 66 and a half years old. So there is a sequencing. There is a gradual development of science. It is not that suddenly there was no science, European came up and everywhere was science. It is nowhere near the truth. Most of the early progress actually comes in Asia. There is some in China, but China remains so isolated that their creativity was not known until much later. So most of the common knowledge developments in science actually come from Asia, Arabs and Indians. The Mesopotamian culture on Euphrates and Tigris, the two great rivers of Iraq, flourished around 3100 BC if you take their peak cultural period. They were urbanized, they had farming, they had work in astronomy, and their work in arithmetic was excellent. They used base 60 because 60 could be divided by 2, 3, 5, 6, 10, 20, and 30. And so when you wanted some fraction of something, using base 60 as a number was more useful. Then Indian urbanization in Harappa starts about 2,700 BC. So our oldest Harappan site is about 7,000 BC, that is 9,000 years ago. The oldest Harappan city is about 2,700 BC or 4,700 years ago. It was contemporaneous to Egyptian and Central Asian cultures, and they all peaked around the same time. These cultures had long trading traditions. So there were boats that would go from India to West Asia and from West Asia to India and so on. For almost 2,000 years, India was one of the most significant centers of learning. Okay. India declined in their knowledge. They got disintegrated. Smaller kingdoms came up. None of them were capable of supporting science and technology. So India begins to disintegrate by about 1300 BC, 1300 AD, and eventually um, it has to be reintegrated much later. So when India declined, fortunately the Arabs were beginning to reach their peak. So they took a lot of this Indian knowledge and stored it for us, and not only stored it, they also added significantly to it. So, for example, deductive thinking and the idea that the way of checking any scientific idea is to experiment, is actually an Arab idea. It is not a European idea. So Europeans would later adopt it, but the first thinkers who thought of experiment as the only way of validating the interpretation of working of nature is actually the Arabs. And it's pity that Arabs are not appreciated as much as they should have been. Arabs themselves don't realize how much science and technology they have. So, what were Indians good at? In the early periods prior to 1000 BC, of course, there was this great Harappan civilization. Its early knowledge system is phenomenal. Its town planning is complex. It's we suspect there are also observatories and their connectivity and their trading and their standardization in an region that covered all the way from central Gujarat or Kutch region of Gujarat all the way to Kashmir. They had the same script, the same writings, the same standardization of house making, the same standardization of bricks, the same standardization of even knives that they made, the micro blades that they made were highly standardized across the culture. The jewelry that they made was across the culture. The usage of sign was across the culture. Harappans were a highly organized, highly centralized culture. It disappeared as quickly. We don't know why, but when it at its peak, it was a very masterful culture of some 20-25,000 people must have existed in various cities. We know of at least half a dozen big cities, and there were probably much larger number of smaller cities. In fact, there were much larger number of smaller cities. It peaked it had hundreds of villages and cities in which people lived. Sulba Sutra come out around 1000 BC, which for the first time mentions Pythagorean triplets, 500 years before Pythagoras. They do not have in general a square plus b square equal to c square for any value for some value and b and c. They simply say that I know of these 2, 3, and 5, etc. Triplets, which I know, and those are mentioned. Pythagoreans knew it, Egyptians knew it. Only Pythagoras went to the general idea of a square plus b square equal to c square. And the reason why Indians knew that is also extremely fascinating. So Indians worshipped gods like all cultures do. And they worshipped various gods in various forms. So there is Indra, there is Mitra, there is the whole by Ushas and so on. There are so many gods out there. And each of them had to be worshipped. But you could not give the same. And the only way of worshipping it was to light a fire and give the oblations to the great Agni, who would then convey it to the gods. So you had to have Havan, and Havan could not be the same for all the gods and for all the ceremonies. So they had to be more elaborate or less elaborate. So Indians very early encountered this problem of squaring a circle. They could make a semicircle Vedi and they could make a square Vedi or a rectangular Vedi. And then they had to worry about making sure that both of them had the same opening area, because otherwise gods will get upset. The one who gets a smaller one will get upset. And so a lot of early development in India is actually driven by this merger of geometry and algebra, how to get the same area for different shapes. So the idea of squaring a circle by a number of smaller element and infinitesimal elements, etc., comes very early, and therefore they have to solve all kinds of series equations, because you can take a semicircle and then square it approximate to a big circle, but there are a lot of areas left out. So you divide it into 2, you divide into 4, you divide into 18, you divide into 16, etc. So smaller numbers have to be added together. And that is the idea of that is the reason why series summations, etc., come out very important. It's a question of trying to project geometry into algebra, trying to get algebraic solutions for geometric problems. The number system, the counting system based on powers of 10 actually is quite old. In Vedic literature itself, there is a saying that may the gods give me 10 raised to 7 cows and so on. And then later literature, there is actually a competition about how big a number you can represent. But they simply say 10 raised to something, and in words, not in numerals, obviously. So while the formal representation comes much later, the idea of decimal system and its powers, etc. So the idea of multiplication and repetitive powers, etc., is quite old. Mahabharata represents the world's first formal constitution of how a king should behave with respect to its subject. So, for example, one of the interesting oddities of Mahabharata is that even the Kauravas are villains in the story, you never hear of the population of Hastinapur or any of the properties of the Kuru kings ever revolting against the Kuru king. The Praja, the people were quite happy with the way Kurus ruled the kingdom. And that is because they had a proper formal constitution which defined how much taxes the king could levy and how much, what was the responsibility of the king, what were the duties of the kings, and in turn, what are the duties of the citizens, etc. So the first constitution of the world on how the what is the relation between the ruler and the ruled, etc., come out in Mahabharata. And there are so many other things, the chakra view and the ways of fighting, how wars are fought, what are the moral rules of war fighting, etc. All of them turn up in Mahabharata. Mahabharata is a complicated document or story, if you will. This is an example of Harappan city. This is the city of Mohenjo-daro. The whole city is in the bed of a river and it is on an artificial mound. You can imagine creating an artificial mount of 300-400 meters by 300-400 meters. This is about 100 meters. And there are other stays, etc., staying places over here. Imagine creating first an artificial mount. And then on that, going beforehand, saying that cities will be orthogonally planned. No entry exit from any house will open in the main street, but they will always open on the side street. There is a common bath where there is a lot of speculation as to who was allowed to go, because Greece also around later on would have this kind of common baths and all that, where major debates, etc., would occur. So this is the great bath of Mohenjo-daro, but you can see how beautifully laid out this is and how it was on an artificial mound. Mohenjo-daro, 2700 BC, is one of the greats of Harappan civilization. Harappa itself is a very great city. Even if you go to Dholapira in India, you will see it's a great city. Then there is a golden period of Indian science, which goes from 1000 BC to 200 BC, and that is a genuinely creative period. It's a late Vedic period. It is also called Nastic period because there was a lot of um, movement away from taking Vedas as the final word for everything, and people are allowed free thinking, etc. Buddhism, Jainism, and other philosophical ideas would come in, and so on. So it was a period of a Nastic period where you did not have to swear allegiance to the Vedic literature. Panini's grammar, 6th century BC to 4th century BC, is the most exhaustive formulation of linguistic grammar. And Panini actually says that this is not my creation, this is just my compilation. University of Takshashila comes in 8th century BC and goes on till 8th century AD. 1400 years is how long Takshila lasted. Even Buddha, the great Gautam Buddha, was supposed to have been a teacher in Takshila, and many Buddhist monks were teachers there. And a lot of both religious and secular literature gets created in Takshila. 1400 years is a long time. Bombay University with 140 years thinks it is a great achievement. Takshila lasted 10 times longer than that. Nalanda University comes up in 5th century BC and dies in 13th century AD. That is also good 1800 years. Keeping a university running for 1800 years is not a joke by any standard. Okay. And they did not decline because students stopped coming because the teaching was not good. They declined because of external attacks. So and there was this great books that came out during that time. There lots of literature comes out during that time, but the 6 great books are define that period very well beyond anything else. So there is this classical books of Nyaya and Vaisheshika system. The Vaisheshika in particular I love, and I will talk about it at length because it's the first genuinely secular book of science. It does not talk about religion, it does not talk about gods, it does not pay homage to anybody. It says this is how nature works, and it is a beautiful piece of literature, and I'll come to that in detail in a few minutes. The books of Nyaya essentially investigates logic. What is logic? Vaisheshika is concerned with the nature, the source, and the limits of knowledge of how nature works. Yoga and Samkhya are the other two great books in the set of six. The first text is the first textbook of medicine, and yoga is simply not asanas. Yoga is a way of uniting between humans and their personal god, the Ishwar. The personal god idea comes in, and it is essentially a very elaborate scheme. So asanas, etc., that we today call yoga, actually is a very small part of the yoga practices. And meditation and coming to union with your great personal god to get nirvana, etc., is part of that story. So yoga is a genuine practitioner. Is yoga simply does not distort his body. There is something more profound to his mind that needs to be done in the name of yoga. Sankhya, on the other hand, investigates the nature of being, its becoming, existence, who we are, why we are, how we are, and so on, and basic categories of being and their relations, who is what, etc. And the last of the six books are Mimamsa and Vedanta. Mimamsa, they are again a classical series of books. Yoga and Sankhya were first millennium BC to early century AD. Mimamsa and Sankhya are 500 BC. Mimamsa investigates the nature of dharma. What is religion? What is morality? What is right? What is wrong? And there is Uttar Mimamsa, Purva Mimamsa, etc. And there were many, in many cases, there were, and the word dharma that it uses is not a religious practice. Dharma is used in the sense of duty. What is the duty of a citizen to with respect to the society in which he lives? What is the right behavior? What is the wrong behavior? What is morally acceptable? What is not morally accepted, etc., is defined in Mimamsas. And dharma is used in a very different sense than religion. And the next is Vedanta. Vedanta investing essentially the metaphysical reality of what this great Brahman is. Note that, I mean, there is no outright religious book anywhere in these six. Okay, they are all philosophical textbooks, or they are textbook. They are books on how to live. Just to go back, Nyaya says what is logic, what is right, what is correct. So inductive logic, etc., comes out in Nyaya beautifully. Vaisheshika, on the other hand, I'll talk to you about in detail. He talks about the nature of knowledge and how much we can understand about working of nature. Yoga and Sankhya. Yoga is essentially personal practice of sort of becoming disease free, but more importantly, become one with the great nature um, through asanas, which give you a physical discipline, and through meditation, etc., which give you a mental discipline. So both your mental and physical well-being are sort of synchronized to the great heavens. It does not define which god. It is now Ishwara. It's your personal god that you pray to. You don't have to go have a belief in any specific god system or any particular religious system. And that is where the sheer genius of that period lies. Sankhya, like I said, investigates being, becoming, existence, reality, what is true, what is false, and so on, in the broad general sense of the word. Are we living in a dream, or are we living in a hypnosis, or are we in a real world, and so on. Mimamsa is a book of logic which defines what is dharma, what are the duties of a human beings living in a society, and so on. And Vedanta talks about who we are, why we are on the earth, what is our role on earth, and philosophical questions like that. So these are the great six books that come out between 6th century BC and early beginning of Common Era. Vaisheshika is a book that I personally find very favorite because it's a beautiful book of physics. Okay, it was written during the great Renaissance period of Indian science, 2nd century BC. It was written after Hinduism had been largely reformed with the arrival of Buddhism and Jainism. So there is a certain unshackling of Vedic thought as the only way of thinking in India, and therefore it brought a degree of irreverence and removed the ancient definitives. What would clock, for example, European religion is this great authority of the Pope. That was removed in India because there were independent thinkers who worked very well. It was also after the departure of Alexander. Ashokan war is 268 to 232 BC, so it's probably around that time or later than that that this book came into being. Um, I have said here that it is at the end of Mauryan Empire, 322 to 185 BC. These numbers I have taken from Wikipedia, and Saikya is not very sure whether my dates are correct. But you can see the spread of Mauryan Empire at that time, going all the way to west of Afghanistan to Brahmaputra basin in the east. Um, it held sway for 1,000 years and became the standard textbook of science. And the idea of Panchamahabhut then finds itself in various cultures. Even in China, there is a concept of Panchamahabhut and all that. But the Panchamahabhut is just one of the catchphrases of Vaisheshika, and I'll come to Vaisheshika in a minute. It held sway over the world thinking for its inductive power, and only the axiomatic approach later on in 16th century in Europe would sort of give alternative explanation to the working of the nature compared to what Vaisheshika did. It consists of only 373 verses. It's not a pothi. It's just 373 verses and multiply by 2. So 700 and some lines of writing. That is all it has. Okay, 373 verses. They're simply magnificent. Okay, and it is completely secular in approach. No God, no Ishvara, nothing. This is how the universe is divided. This is how the physical world is divided. And this is how it works. And this is what it says. He says the universe consists of matter and material. The most important is dravya, which is material. So dravya can be solid, liquid, gas, sky, and energy. Then there are two active elements to this dravya, which is kala and dika, time and space. And then there are two more life forces, which are mana and atma. So atma is general consciousness, mana is mind where people think. So this is for plants and animals and everybody. Mana is for animals in particular. So already they are talking about there not being a great distinction between other animals and humans. That is a question of degree, is implicit in this thought. Then everything has guna, properties, and it has color, taste, odor, touch, feel, temperature, if you wish, number, measure, distinctiveness, conjunction, disjunction, otherness, difference from one to the other, similarity between the two. Um, so this is a book of science in general. It is not physics alone. So intellect, etc., comes as a part of biology. Happiness, unhappiness are all biological entities. Then there is desire, there is aversion, there is effort, there is heaviness, there is fluidity, there is oiliness, elasticity, and then there is righteousness, demerit, and then last one is sound. Sound would have should have gone up here, but that is how it is organized. Then the third item is karma. Karma says movement up, movement down, contraction, expansion, and displacement. These are essentially events that happen in time. The fourth entity is Vishesha, specific properties. So something may have green color, something may have yellow color, and so on. Something may be square, something may be circular. So Vishesha, these are specific properties of specific entity you're talking about. These are general properties. Then there are inherited properties. If you take brown colored mud and make it into two pieces, both of them will be brown because it is inherited property and so on. And then there are samanya, common properties to everything, which says everything exists, everything is transient, and the cause and effect. And this is a non-trivial creative idea, cause and effect. It explicitly says that effect must follow cause. The cause must precede effect. Nothing happens out of magic. Nothing happens out of God's creation. For every effect that you see, there is a cause. And this causality argument that is central to everything science actually appears in Vaisheshika for the first time, which says that cause must precede effect. So let me look at these things in a little more detail. So here there are physical manifestations of matter, the Panch Mahabhut, solid, liquid, gas, sky, and energy. Then there are life forces, Atma and Mana. Then there is time in between the active entities. Then there are emotions, happiness, unhappiness, desire, aversion, effort, and so on. Then there are motions, movement up, movement down, contraction, expansion, and displacement. Then there are quantifiables, color, taste, odor, temperature, number, measure, and so on. And then there are physical properties, fluidity, oiliness, elasticity, and sound. Rightness and dimension should, of course, go up. But the listing of 24 is in this order, so I've kept this order. And this is chemistry, distinctiveness, conjunction, disjunction, otherness, similarity, and so on. So essentially, major properties of universe are covered here. How do you read Vaisheshika? So the first thing Vaisheshika says is causality must be there. Cause must precede the effect, and anything that has an effect must have had a cause. Okay, there's no magic, there is no God's interference. Everything is cause and effect. Nature of matter. He says substance is made of material that has property. So it is dravya, which is the Panch Mahabhut and so on. They have guna, which together make them a padartha. The material and its properties make them a padartha. Then there is conservation of mass. Dravya can neither be created nor be destroyed. It can be deformed by karma, but otherwise it can neither be created by destroyed by karma or physical action. Remember, you are writing at the time of 200 BC. It is not a 20th century document. It is 20th century BC document, or more like 200 BC document. It says properties of matter. Gunas are destroyed by cause and effect. While mass, dravya cannot be destroyed, gunas can be destroyed. I can take a yellow colored object and paint it green. I can change its gunas, but I cannot change its dravya. The motion is a result of karma. You have to do something to get something to move or something to stop moving. Karma can only be opposed by karma. You have to stop something from moving for it to stop moving. And I'll show you that old slide again for you to appreciate this again. But karma can only be opposed by karma. The change in state, you can change the guna through karma. You can beat it up and break it into a flat piece of whatever you need. You can add material to it and make it heavy or so on and so on. So guna is changed by karma. So just to go back to the same property, karna, the karma, the movement up and down, etc., are physical manifestations. They can change only the guna. They cannot change the dravya. This is conserved. Well, this is not conserved because it can be altered by karma. So Vishesha properties that a material may have eventually can be changed by through action. Okay, and Samanya properties exist universally. So, for example, if you want to know how fire is lit, it says you take liquid, um, um, any liquid, essentially kerosene or some fluid like that, or solid like wood or something. You give energy to that, as a result of which you will have conjunction of air and energy and wood in the presence of air, and that conjunction will produce a gas and will produce more energy. And it will also produce an odor for you. And but it will be hot, it will be hot to feel and so on. If you want to understand how motion occurs, you say that take the solid, it has certain Vishesh properties. So currently it is at standstill or at moving uniform velocity or whatever you have it. On that, you cause a displacement to happen. In the displacement to happen in the property of direction as to where it is going, and in time it must happen, so that you have motion. And the Vaishesha properties of this material changes because of this. So it's one of its gunas changes because of that. So that is how you can read almost any physical phenomena as long as you're happy with qualitative explanations. This book is actually good enough. And it is not surprising that it was a classical textbook of physics or science for good 1,000+ years. Renan Martin is what, 100 years old. Renan Martin, Resnick and Halliday is about 100 years old. So the idea of Parmanu is there in Vaisheshika, and the idea itself is very interesting. It says Vaisheshika presented the following synergism. It says assume that matter is continuous. Take a stone and then you can divide it infinitely into many pieces, and therefore Himalayan mountain range can also be made from these infinite pieces. And so you can just build anything from anything by just chopping it to infinity, which absolutely is a paradox. And therefore we must assume that the universe material is not continuous, but it has Parmanus. And these Parmanus are individual, eternal, and they can neither be created nor be destroyed. Each Parmanu possessing its own specific properties, distinct Vishesha individuality. And the logic, of course, is not fully correct. You can argue saying that only so much can be done. But the basic idea of proving by something by contradiction and so on, and developing an idea along these lines is a great development for that period. It is also from the modern definition, it is far from the modern definition of atoms and periodic table, but that's a different part of the story. Anu and Parmanu are properties that make it a physical entity. Artha, Apa, Teja, and Vayu. Artha, Apa, Tejas, and Vayu have Anu. Space does not have Anu. Transition from Anu to modern 20th century is a 20th century reinterpretation of these statements. Then comes a third period of great creativity, which is Siddhantic period. Siddhant is concept. So mathematics become more conceptual and so on. So formulation of astronomical problems in mathematics, invention of trigonometry. But towards the end of 16th century, Kerala school also comes up with limiting value theorems and so on. Formulation of algebra of zero, as we saw in the last lecture. Kerala School of Advanced Mathematics did phenomenal work in series and also came out with limiting value ideas and stuff. Modern period, I hardly need to say, it begins with the great architecture of Taj Mahal. Tipu Sultan's rockets were their own great creations of that period. Development of mining and metallurgy. So zinc is an older period, 500 to 600, 1600 period. But today, of course, we have metallurgy and we have too many advances in textiles, warfare, art, literature, shipping, etc. I won't even talk about the modern period. But that is how you would divide the development of Indian science. The modern period is entirely influenced by intercultural exchanges. Till here, things were more or less isolated in India with occasional exchange of ideas. But modern period is completely homogenized across the globe. Transmission of knowledge to the world. India was an acknowledged source of knowledge for a long time. When India declined, as all cultures inevitable to do, a little before, incidentally, the arrival of Mughals. It is not the Mughals who brought the downfall of Indian science. Indian science was already in decline because Indian kingdoms were in decline. There were so many small kingdoms that none of them was rich enough to sustain the funding that is required for science, the common knowledge, educational systems, etc., that required state sponsorship, just were not possible in these small kingdoms, and therefore, naturally, the entire culture eventually came to decline, and therefore, Mughals could so easily walk in. This knowledge was taken up by Arabs. When Indian knowledge was beginning to decline, Arabs had sent a whole bunch of scholars to document Indian knowledge and to expand on it. And so we need to thank Arabs for this preservation of this knowledge. The Arabs did a great job of documenting, preserving, and working on this knowledge. So they actually built up a lot on this knowledge. Um, earlier with earlier with Europeans, they had done the same earlier with European works during Greek and Roman times also. So, in fact, when the Europeans come out of Dark Ages, they really had no idea what earlier work looked like. It is thanks to the it is thanks to the Arab documentation that they came to know about Socrates and others. Arabs, incidentally, were the first ones to suggest that natural knowledge should be validated by experimentation, by formal experimentation, that laid the foundation for experimental and eventually deductive sciences, scientific study of nature. We don't appreciate and we don't give credit to the Arabs for this. So then they then transmitted this knowledge to the West when West matured, and West built up on this and eventually went on. They changed the approach from inductive to deductive, but they built up on this in a great way. And eventually we had um, industrial revolution, the Great Renaissance, and so on. But I would even argue that that approach is now reaching its limit, as our ability to study simplified system is becoming, is becoming more or less complete except for quantum mechanics and so on. Deductive approach is no longer going to work because so many forces and um, actions happen that you can only approximate what the final result would be and would not be able to have this classical deductive firm answers. So there are shortcomings, but having said how phenomenal some of the great achievements were, we must also confess that there are limitations. The first limitation is that even Vaisheshika itself, for all its labor, says that the material behaves the way it does because that is its nature. It's the prakriti svabhava of that element, and he does not investigate as to why that material has that property. So chemistry doesn't come in. Description of nature therefore reaches a plateau very soon. Imagine having the same textbook for 1,000 years means you are really not adding significantly to it. It remained an intellectual pursuit of pure form, and that would be the eventual bane of Indian science. So students of science avoided direct experimental studies, which would require working with artisans. They didn't do that; it was below their stature. Building Harappan cities of like Taj Mahal, which would have needed understanding of a lot of relevant sciences, but they did not lead further. The learned class would not even document properly how Taj Mahal was built. We are forced to sort of speculate the layout and design of the original Taj Mahal, how it must have changed, how they must have found errors, how they must have improved upon the original design, and so on is something we don't know because it was never properly documented. Social stratification ensured that the subjects such as mechanics were not mathematically studied, and that would do a lot of damage to India. Then there are some fields that we completely missed. Gravitation, thermodynamics, electromagnetism, and structure of matter. We totally, completely missed these fields. And there are two more, optics and mechanics we've missed. We have glass in India going back to probably 1000 BC, but it was never used to make lenses and things. So optics, classical mechanics, similarly, we had no way of doing molecular biology or genetics simply because if you didn't even have optics, there is no way you can look at molecular origin of life. And the corresponding technologies were never realized. Most importantly, there was no electricity. Remember, because there was no electromagnetism, there was no electricity. Large or even a consistent structural pattern by which you could do experimentation and all that. So question of air and space travel, etc., uncertainty principle are simply just not there. While there was a general idea of relation between disease and other life forms, absence of microscopes made several fields were left out, even though glass was made known by that time. So, yoga and others talk about illnesses and five kinds of personalities and diseases and so on. They do not go into molecular biology or cellular biology or germs and viruses, etc., because that experimentation idea was not there. So there's much that to be proud of, but we don't need to exaggerate. Okay, it is fashion. I'm going to skip this. Okay, it's exceptional, fashionable today to make exaggerated claims. So there have been claims like quantum mechanics we knew, now uncertainty relations we knew, Vimana and interplanetary travel we knew, genetic engineering we knew, trans-animal exchanges we knew, atom bomb we knew, internet was known because Mahabharat was recited by um, at a great distance by Sanjay to Dhritarashtra, and that must have been interpreted. Not even telephony; it was internet by which he did that. Atom bomb claim that because of the great destruction that arrows did in. Let me go back one by one. Quantum mechanics. Quantum mechanics arises because there is a conflict between thermodynamics, classical electromagnetism, and structure of atom. None of these three things were known to people at that time. So there is no way they would have realized that at the microscope, at a nanoscale, matter behaves very differently. There's a talk of Vimana and interplanetary travel. For interplanetary travel, you have to know a heliocentric model of the Earth. You have to know the distance between Earth and Mars. So there are people who claim that they have seen in NASA pictures, they have seen helmets of two great kings fighting on Mars. Going to Mars is not a trivial entity. You have to know heliocentric model of the Earth. You have to know the distance between planets. You have to know how to travel these distances, etc. None of these exist. Genetic engineering, of course, requires first understanding of cellular life, then molecular life, and then other things. So just because there is a character of Shikandi in Mahabharata doesn't mean we knew gender changes. Trans-animal exchange, because Ganpati has an elephant head, we knew trans-animal exchanges. Even now, it is impossible to do trans-animal organ transplant except in very rare cases. You can take pig's liver into humans and so on. But by and large, it is just not possible. The brain would not work, the head would not work, everything would not work. So Ganpati is essentially a figurative idea of, because elephant is such a beautiful animal with its great capacity of memory, etc. They imagine a superhuman god who has all these abilities, but it is not that somebody actually managed to transplant the head. Atom bombs are supposed to have been there because Mahabharata time great arrows were thrown, which created great destruction. Atom bomb requires you to understand fission, fusion, um, fission, triggered fusion if you want hydrogen bomb, but triggered fission for uranium. You had to know the elements existed. You had to know the periodic table. You had to know that uranium is unstable. You had to know that you can exploit that instability by increasing by compressing it and so on. None of these technologies existed, or none of this knowledge existed at that time. There's no sense in claiming that we knew atom bomb. Similarly, internet is what Sanjay is supposed to have used, which is obviously not true because internet is integral to having electricity and communication wiring, etc. These just didn't exist. So sometimes when some claim is made, it is good to go back and look at what were the background technologies or knowledge that would have been retained to reach a particular level and then decide whether the claim makes sense or not. And so with doing this without demonstrable capabilities is not does not validate the idea. So and it only gives a lot of very honorable research done by very great scientists of India today is simply thrown out with the baby is thrown out with the bucket, saying that all Indians are fanatical, irrational people, which is not true. Good, honest research is being lost in this. China had incidentally somebody called Needham, a European who went and stayed in China, and for several decades he systematically documented European Chinese research, and there's a whole institution called Needham Institute which still produces books of various evaluating various scientific technologies, so that no wild claims can happen. I mean, anything that you have, it would have to be validated by the Needham Institute. We probably need an institution like that. So just to go back, scientific knowledge is without Vaisheshika, Newton probably could not have happened. But Vaisheshika could not have anticipated Newton. Accumulation of our understanding of the working of nature is incremental, and no scientific growth is isolated. Every idea on how nature works is tested by theoretical works and experiments. The history of science is littered with people's great creative ideas which turned out to be not the ones that nature obeyed. And only experiments can check whether one idea is correct or the other idea is correct. Experiments are the final arbiters of competing ideas, and we didn't have this culture of experimentation. We didn't have the technology, we didn't have the idea. Scientific knowledge, therefore, is objective and testable and not opinion based. Wrong ideas, however attractive, are eliminated by science. Broadly, anatomically, the modern science arose over a million years. The first scientific experiments were done by human beings a million years ago. And about 2 lakh years ago, once Homo sapiens came, they had the greater intelligence to or brain to body ratio, and therefore they could assimilate better. They entered the subcontinent between 70 and 40,000 years ago. They learned farming about 10,000 years ago. They set up the first cities about 5,000 years ago. And Sanskrit speaking Indo Iranians entered about 4,000 years ago. Evidence for Harappans is entirely archaeological, while the evidence of Vedic people is entirely textual. This has been one of the great problems of Indian prehistory, that they are mutually inconsistent. This timeline is fairly well established, even though we do not know the connection between Harappans and the Vedic people. Um, so just as said, quantum mechanics arises from electromagnetism and thermodynamics. Aeroplanes required understanding of dynamics of air, wind, and Bernoulli's principle. Um, we need industrial revolution to make internal combustion engine, which started with steam engine. Before you can make heavier than air machine which can fly fast enough to use Bernoulli's principle and the lift in order to fly. Interplanetary travel, of course, requires understanding of planets and heliocentric imaging and the distances and the rockets and so on to leave the gravity of the Earth. And you require the basic mathematical foundations to do that. You require experimental facilities, test facilities, manufacturing facilities to be able to do that. There is no evidence of industrialization of the subcontinent until 20th century, 19th century. Similarly, genetic engineering requires you to understand molecular life at molecular level, the centrality of carbon in life, the double helical structure of the life's molecules, microscopy, electron microscopy, and ability to manipulate molecules, isolate these cells in extremely clean and low temperature environment, and study them and manipulate them. Similarly, atom bomb requires uniqueness of atom and so on, um, and how to compress them, etc. And even today, we are quite convinced that any atom bomb will be so heavy that you can't put it on a bow and arrow. No individual human will be able to carry such payload. More importantly, these achievements needed powerful mathematical tools. They needed electricity. They needed clean environment and appropriate structures. They needed large scientific manpower with an elaborate state system of education. Um, and so on. The arguments that talk about the past happily mix 16th century mathematical development with 3rd century ideas of philosophical ideas and stuff like that. Doesn't happen. Even the past has a certain sequence. It is clear that so clearly many of the claims are not tenable. None of these claims are predictive. We have never heard saying that such and such an ancient text predicts this particular property of the nature and you please go and test it and we found something new. That has never happened. It is never predictive. The bottom line is that there is a hell of a lot to be proud of in ancient Indian past. Vaisheshika still is a very beautiful book and could easily be used in school level science to give the children a basic feel of how nature works without the mathematical foundations. We don't have to manufacture false stories. Our rishis were profound thinkers for their own period. The person who Kannada who thought of Vaisheshika was a genius of philosophical ground, not to mention Aryabhatta and many others, Panini and so on. But they never had the experimental backup that would have let them test their ideas objectively and take them forward. So let us not make false claims about Indian sciences and in a preemptive manner um, about modern sciences. The question is, if this is true, then where have all these developments gone, and where is the evidence for it? So there are people who have come and there are people who have come and told me that look, just because you don't see the evidence doesn't mean the evidence doesn't exist. And the obvious answer is that if I take a blank answer sheet to an exam and say that the teacher should give me full marks because the teacher should know that I had everything in my mind, makes no sense. To validate how much you know, to evaluate what you know, it has to be in written writing somewhere, and that we have not found. So please, by all means, we have every reason to be very proud of the achievements of ancient Indians, but we don't need to have it validated by the developments of modern science, which were built up on the ancient Indian studies, but they were built up. They were extra structures that were subsequently built up, and therefore they could not have existed in the deeper past. So we should be balanced, and we should think for ourselves. There are things, of course, without Vaisheshika, like I said, Newton would not have happened, or without Aryabhatta's mathematics and zero of Brahmagupta, there is no way the algebra of Europe would have existed or developed. All that is true, but don't tell me we knew quantum mechanics. Thank you very much.
Okay,
I'm sure
thanks
this
very
is going to
much.
create a lot of discussion, so I've left more time for it.
Thank you, Mayank. So any questions,
My pleasure.
comments? Mayank, maybe I'll start off with just a small query, which
Sure.
where you put the invention of trigonometry in your slide as 500 to 1600 common era.
Yes, it's
Yeah,
more like 500.
but
Bijganit comes very early in that 500 to 600 period.
okay, but
Yes, sorry.
I thought that trigonometry was much older, right? Study of triangles was there in Egyptian times, in the Rhind papyrus,
Ah,
Babylonian times.
yeah, but formalizing of angles as sine theta and cos theta is not there. Triangles are there. So Pythagorean triplets are known in Sulabha Sutra, in the first earliest period.
Mm,
The
okay.
idea of triangle, the area of a triangle, the area of triangle and a semicircle, area of a triangle and a circle, all that is there.
Hmm.
Okay, the algebraic geometry of early period all the way from Sulabha Sutra is very impressive.
Hmm.
But the
Hmm.
idea of opposite side upon adjacent side is tan of a function and so on is
Hmm.
formalized by Aryabhat. In fact, Aryabhat he is very apologetic. He says, "Look, this Aryabhatiya is not a text, not my book in the sense that it is more encyclopedic of all the current knowledge in mathematics, and
Hmm.
everything is not my creation."
And
So
that was
some
about
of these ideas would have predated
yeah, and
500 AD.
that
He
was about
actually, yeah, he actually that
hmm.
is 500 AD, exactly 500 AD, because he actually notes down that I am writing this book on this particular day, and that day
Okay.
can be checked back to 500 AD.
Okay. Okay.
So
Okay.
that's how we know it to the nearest year.
Okay.
There are some question in the chat box. There are four of them, in fact. So let me go
Okay.
one at a time.
We'll go one at a
Okay.
time.
Yes. Please recommend books for these textbooks. Now, all these textbooks, all the six books are now available in English translation, so you can trivially read them. And for example, don't know Sanskrit. So even though I like Vaisheshika so much, I have read only translations. But each translation has its own bias. So it is good to read two or three translations before you are clear about what is the author's opinion and what is actually in the book. So you need to be careful about that. But in all these cases, if you ask for Amazon, it will tell you. There is also a Government of India site called Rare Books, etc., where it is there. Nyaya, of course, I have glossed over a lot of things. So, for example, Buddhist system of Nyaya is different, Jain system is different, contemporary Hindu systems are different. There are subtle differences. Even within Buddhist system, there are multiple schools and so on. So there is a lot of discussion, there is a lot of argumentation, there is a lot of opinion, there is a lot of conflict even between schools and so on. That part of the story I have avoided, partly because I'm not an expert on that, and partly because these stories are very subtle and very complex. But there are schools, even within Buddhism, etc., which actually discuss whether their interpretation of the original reading is correct or not, and so on. Even Puranas, etc., have variations within themselves, and even Vedas have, at least Yajurveda has a black Yajurveda and a white Yajurveda, etc. So there are disagreements, agreements, discussions, etc. So everything is not as straightforward as I said. But within the Naya group, it starts around that time where I mentioned, and then the ideas develop much more and much more profoundly in future, in subsequent times, and there are commentaries and there are books and there are translations of all this. Then there is a question of architecture. Now, architecture is something I have not talked about. I should have talked about. I only mentioned Taj Mahal, but temple architecture of 12th century is phenomenal. I think the temples, incidentally, in India are not original in the sense that um, the early Vedic religion depended on havans and Vedis and sacrifice through fire altars and stuff like that, and had no permanent place where this should happen. Then what happens is that Hinduism goes into decay with all kinds of exploitations, etc. So several major re- revivalistic movements come in. Buddhism and Jainism are the two that have survived very well. And when Buddha passes away, they make a monument of his remains. And various students want it, so his hair are distributed at various places and so on. And so they make these stupas in memory of the great Buddha. And very soon those stupas become the central places where people can meet. So you could call all your Buddhist colleagues to the stupa, and then you could have your discourses, you can publicize your religion, etc. Hinduism had no such foundation, but they saw the power of this structure which could gather your people. So that is when temples come up. There were some temple ideas which are originally cave based, but they were not necessarily of the mainstream Hinduism. So some of the tribal peoples had this cave temples, etc. But Hinduism formally adopts to temples only as a response to Buddhism, and then the architecture takes its own course. So this, I mean, since I have time, I might as well talk about it. So the temples in India are largely two styles: the Nagara style, which is followed in the north, and the Dravida style, which is followed in the south. And the central Garbhagriha, where the god sits, is actually an image of the cosmos, is the image of the heavens. So the god sits in the middle, and specific gods are supposed to sit at specific locations and all that. It's not random. It is not that if you want to build a temple, put the murti around it and put a temple around it. You can't do it that way. There is a whole shastra for a temple. So you first set up a pillar, which is eventually becomes dvaja and stuff like that. So there is that stamba. That stamba you follow for a year and get directions. Then you decide in which direction you want to set up your temple. It may be on vernal equinox, it may be on summer solstice, it may be on some other day of importance or something. And then you start laying out the foundation. In Nagara style, the central place where the god sits is kept is the most glamorous one with the biggest dome and all that. And the priest goes inside, and very few people can go inside. And then outside there are two chambers where the kings, and then in the outer chamber the other people can sit and worship and listen to prayers and so on. In Dravida style, you have a central Garbhagriha, which actually is not as spectacular. It is the gates that are spectacular. If you look at Meenakshi Mandir, for example. And the idea is that even though the Garbhagriha is a representation of the cosmos, the great four directions, north, south, east, west, are celebrated with greatest flair. There is some discussion that was probably also worked as a defense mechanism to see if somebody was attacking, etc. But that is unlikely because South has not seen half as many wars as the North has seen. So South is not triggered for, not designed to handle wars. So southern temples have this beautiful style of great entrances to sort of welcome you, and then the Garbhagrahas are relatively mild, and they're laid out as if a human being is riding. So the gods are where the head would be, and the dwaja would be where the male penis would be, and then the temple is laid out with various structures. So their structures are different, their interpretations are different. So temples are a completely different ballgame. And this starts in 6th, 7th century AD in response to Buddhism. And then by 12th, 13th century, I mean, the complexity and the structure of temples is simply fantastic, simply unbelievable. There are also stones temples and there are also brick temples, which are relatively rare. But in Hinduism in India, uh, Shaivite temples and Vaishnavite temples are different. If you go to Southeast Asia, you get these Harihara temples. There are a few Harihara temples in South India also, but in East India, you get this, Eastern Asia, you get this Harihara temples where both Vishnu and Shiva are worshipped in the same temple. So there are variations, there are various issues, there are various developments. The structuring of the temple, I mean, one could, if you, and the finest and the most beautiful Hindu temple actually is in Cambodia. It is in a place called Angkor Wat. The temple perimeter is 900 meters by 700 meters or something. Okay. 900, it's almost a kilometer wide. Remember that. And three-fourths of a kilometer long. Rather, a kilometer wide and three-fourths of a kilometer long, the other way. And as you enter, it's a magnificent temple. If you have some money, you should go to Angkor Wat and see it. As you enter, there are these three great stumbas which correspond to winter solstice, summer solstice, and the thing. And the entire outer periphery of this temple is filled with water, and it follows the cosmogonical interpretation of this thing of Hinduism to great detail. So the Mount Meru is in the center, and then there are layers and so on, and each layer has its own complexity. And the lowermost layer has the most number of carving. And as you go up, the carvings become simpler and simpler because the world is supposed now become more amorphous and so on. Every little detail has been thought through thoroughly. So you to walk 100,008 steps to reach the Mount Meru, and then Mount Meru is at the highest, and then the supporting peaks outside is water, and that is non-trivial. It's what 700 years old, because the water levels tend to change between summer and winter and between a drought year and a wet year. So they have special systems by which they make sure the water doesn't go below a certain level, and even when water drowns a little, the imbalance in the soil should not destroy the temple. It's an unbelievably complex and beautiful temple. um, compare, nothing in India compares with what is at Angkor Wat. So the culture has traveled, the religion has traveled, the architecture has traveled. Architecture has merged philosophy with religion and cosmos and so on in a very elegant manner. But that would require another lecture by somebody who's more of an expert on this than I am. Yes. Any other question? There are six more. Should we trust quantum mechanics or not? I really don't want to have a fight about physics as universe. But what we do know is quantum mechanics is a very peculiar problem. The problem is that it works. The question is, why does it work? Well, I mean, the equations work. The mathematical language of quantum mechanics has been shown to be experimentally consistent. If you can't get a visual image of what is happening, that is not nature's problem. That is your problem. Is light matter or wave is a conflict that is in your mind because you are a visual animal and therefore you like to have visual images. But that is your problem. Nature is not bound to be visible to your imagination or bent to your imagination. That's your problem. As far as we know, the equations that define quantum mechanics work. And therefore, quantum mechanics is to be trusted. The laser pointer, that not this laser pointer, but the classical laser pointer works because quantum mechanics works. The GPS system works because quantum mechanics works. There are so many technology that we have today which work because quantum mechanics works. So we know that quantum mechanical equations and physics is correct. Why is it correct and what is the kind of physical image you can get? Nature has not made that life simple for us. But that is our limitation, not nature's limitation. The next question is, can you tell about ages or dates of all the Dashavatars? No, I can't. So Dashavatars are an interesting set of ideas where you have these 10 avatars of Vishnu, the last one of which is yet to come. And then there is Krishna and Balram. The two of them are together. Mahabharata is typically dated to about 1300 BC. About 3300, 1300 BC or so. About others, we don't even know what it means, in the sense that historical Buddha, Krishna, and Balram are known, are historically referred personalities. Others are not. So, how did they imagine that life arises in the fish, and then there is um, mm, there is that other avatar, Vara avatar, etc. We don't know on what basis they have founded these images. And therefore, there is no question of dating them in any absolute sense of the word. When were these ideas thought about? I'm afraid I don't know. When is the first mention of Dashavatars? I have no clue. I'm sorry for that. But yeah, Dashavatar, not all the characters have historical references. Could you please give some references? Um, I really do not know what references to give. If I were you, I would go to Amazon and type Vaisheshika, and you will get 6 or 7 books in English translation you can get, and you can pick up any one of those. Then they are not expensive, by the way. 160 rupees, you can buy the entire translation of Vaisheshika. There are attempts for environmental conservation. Environmental conservation is something that Indians have been implicitly very sensitive. So the nature is supposed to exist, and we are only borrowing from nature. That idea exists very early in human life. There is a question, of course, Krishna talks about duties and so on, and Mahabharata talks about burning up a whole area to build his cities and so on. So in Mahabharata, environmental sensitivities are not all that great. But subsequently, there are so many movements that have come up. There are so many other things that have come up, which have talked about environmental sensitivity, which we must live with, because eventually we are nature's agents, and we must be careful. Um, and then it's a question of interpretation. Gandhiji sees ahimsa also in the right in the middle of Bhagavad Gita, even though it is in the middle of the war. So many of these questions are of interpretation. But environmental sensitivity comes much later in Puranas and so on. That's all I know about these things. The National Education Policy um, includes a course in ancient Indian knowledge system. It is possible to include the history of science and development in India. Actually, this cause of what should be included in ancient Indian science is something that I've given a lot of thought to. I personally think that it would be nice to familiarize with this Indian logic system. Also, how did this purely mathematical structure of Siddhantic period comes in? Harappa, etc., is covered in history, but maybe we could also have sections on technologies of Harappans and so on and so forth, which would make nice additions to this story. Zero, of course, and questions like those should be discussed. So, I'm a little worried about the burden of the modern education syllabus on the children. So, how much should we put? I personally think it should be simply compulsory lectures without exams, because it become too much of stress. But yes, Vaisheshika should be included. All these 6 grade books should be included. A bit more of Harappan technologies could be introduced, etc. But it should be limited to what the children can grasp, given that they have so much of modern syllabus to learn. The modern information is increasing exponentially. I didn't have to learn computers when I was in school, and my brain power is no worse than that of today's children. So they are only going to be able to absorb so much. So if you try to put everything in, nothing will get through. So we do need to worry about balancing the syllabus. But yes, it would be nice to have some sections about um, ancient Indian sciences, because it is good to know how science evolved, how thoughts evolved, how ideas evolved. Currently, the view is that science is something that is done by great minds and great people in isolation, and it comes out as magic. The fact that science is a human endeavor where people have made mistakes and people have got it wrong, and even the greatest of people have thought of things which nature has disproved, etc., would be nice to give them an idea that science is a human endeavor and that mathematics is a human created language. But one should worry about how much we are burdening the children. Let us know about how to access these material. That is a good question. I don't know the answer. I mean, as Saikia pointed out, I've been doing this for last 20 years and doing nothing else. So I've had time to go through all kinds of books over all periods of time. Some of the book, many of these books I have forgotten. Many of the books probably don't even exist. I really do not know. So I'm sorry if I'm at a loss of this, but at least topic specific. All the great six books, for example, are available in translation. Civilization, Technologies of Harappan Civilization. There are some nice books written on it. There's a very scholarly book by Rita Wright on Harappan civilization. But some of these things require some amount of background knowledge to be able to follow. But there are some general books also. So I'm not able to give specific example, and I'm really sorry for it. All I can say is type in the topic in Amazon, and you will find translations of almost everything that I said. So Aikaji, somebody wants the full length content of today's lecture. And Archana says, thank you very much. Thank you, Archana, for your kind words.
Thanks very much, Mayank, and thanks very much to all of
My
you.
pleasure.